In this first question, a mountain climber is rappelling, and we know that it's 25 meters that he's rappelling. We know that he weighs 72 kilograms. We also know that his velocity is 5 meters per second. What we know because of that velocity is we know that initially his VI would have been 0 meters per second, and we know that this velocity is his final velocity. What we're looking for in this case is we're looking for work, and we know that our work is going to be our change in our kinetic energy plus our change in our potential energy. We do have a change in kinetic energy because in this case we have a velocity final and we have velocity initial. So we can say that we know that it is going to be our EK final minus our EK initial. Our potential energy is just staying the same because it's at the initial height that he was at. So for our kinetic energy, we know that our kinetic energy is going to be equal to half mv squared, and we know that our potential energy is going to be equal to mg delta h from 6.1. So we can put down that we have half mv final squared minus half mv initial squared plus mg delta h. And now we can put in all of our numbers. This should be subtraction. So here's our kinetic energy. We have half times our mass times our initial velocity squared, subtracting half times our mass times our final velocity, and that's a 0 squared. And we're going to add this to our mass, which is 72, times gravity 9.81, and our height, and in this case because we're moving in a downward direction, we have negative 25. When we add all of those up, we will have 900 minus 0 minus negative 17,658. And when we put our answer into significant digits, we have negative 1.68 times 10 to the 4 joules. This second question is asking about a cannonball at the peak of its trajectory. And it told us that we have our velocity, we have our height, and we have our mass. What it's asking for is mechanical energy. And we know that our mechanical energy is simply the sum of our kinetic energy and our potential energy. So we can put in here that we know that our kinetic energy is going to be half mv squared, and we know that our potential energy is going to be mgh. So I can say that my kinetic energy is going to be half times my mass, which is 5.2, times my velocity, which is 160 squared, and I'm going to add that to my mass, which is 5.2, times gravity, 9.81, and my height in this case, because it's not asking about dropping or anything like that, I can just put my height in as 1,200 meters. When I do the math on that, I will get 66560 for my kinetic energy. I'm going to add that to my potential energy, which is 61214.4, and when we add them all together in scientific notation and significant digits, I'll get 1.28 times 10 to the 5 joules is the mechanical energy of that cannonball at the top of its trajectory.